we're going to start today by going over that worksheets that you were given yesterday, and making sure we kind of understand all of these and what they're asking and how to use this limit notation. So you'll notice that this isn't saying to evaluate. I don't know what J is. I don't know what W is over here, but it just says to rewrite each limit notation in terms of the derivative of a function. Okay, so this one, the derivative, like the function we are talking about is J. And I can see that because I have J written here and here. So J is the function I am working with. Now I want to know, like, where am I, what's my A value? So my A value is 4, because this is that first format. So what this question, this format is really a question, is asking you, what is J prime of 4? And that's all I'm looking for here. Like, I'm just asking, what does this notation mean? Well, this is your difference quotient. You have a limit going to 0, so the change in these 2 points is 0, so they're the same point. So this means instantaneous slope. Instantaneous slope is derivative, and then I want it at 4 for this J thing. So doing that same idea over here, this is that like second notation version of it where I have X going to a value, and you notice if you plug in -5 here, you get that 0 in your denominator. So this is the formal definition of a derivative, and all that notation means is W prime of -5. Because your W is your function, and that's where you want, that's the point you're sending these 2 points close to find that instantaneous slope. All right, going to 3 then. Now 3 asks you for an average rate of change. So average is just the difference quotient. So tell me a change in Y and tell me a change in X. So when I look at my interval, it's 0, 7. So at 0, my point is 0, -2. At 7, I gotta find, here's G of 7. I am at 1. So this is just slope then. So I would have, we'll do 1 minus -2 over 7 minus 0. So it's just 3/7. Okay. Average rate of change, that's just the difference quotient. And so take your 2 points and find the slope. Now, if we're talking the instantaneous rate of change, that's a derivative. So, and I want it at 2, and I can see G is everything about here. So G prime of 2 is what that means. So I go on my list, and I start looking for, all right, here's G prime of 2. That is 0. All right, now here's the 5th one. This was in the video introing this, so hopefully you already know the answer to this. But we have H going to 0. We have this divide by H. So this thing is your formal definition of a derivative. So just like up here, I want to figure out what am I taking the derivative of and where. So I can see that I'm taking it of G, and then I can, like, this is the A plus H, so I am taking it at 3. Now, if you're wondering why there's a 4 there, it's because of this right here. G of 3 is 4, so here's plugging in the A value, the 3, and then that's where that 4 comes from. So now I look up here and I say, all right, G prime of 3, well, that thing is just 5 from right here. These questions are not every one is the formal definition where you have all this algebra and you're simplifying and it's 6 steps. Sometimes it is a notational recognition that it means derivative, and then you just get the derivative from a picture or a chain up here. So when I go to 6, I have, this is the delta x version. I'm still talking about G. I now want my slope at 7. I go up here, the derivative at 7 is -2. Okay. Now 7 tries to trick you, but don't let it, because you're going to 0, it's like you have a -0 there. So this really is like that second format that I had talked about. So this is just what is G prime at 0, and G prime of 0 is -3. All right, the bottom ones gives you, so it says the graph to the right shows f prime for some function f. When I read that, please, with 100% fidelity on as we go forward here, please write a gigantic f prime. That is what this is. So when I go down here and I start asking you about f, I don't need to go to this picture and start being like, okay, where am I at 3? Okay, I'm here. What is happening? these two things, they're related because they're both f's, but this does not just, this isn't the graph of anything to do with this. Just the fraction. When I put the limit in front of it, now I'm sending the difference in y's and the distance between them to 0. So this is really asking me what is f prime of 3, because this is the formal definition of a derivative. Well, now that I know I want the derivative and I have a picture of the derivative, I can go to 3, I can go down here, and then being careful, I don't find the slope there. I find the y value, which is -2. Because remember, these points are like x, all right, slope of f, or you say m. I don't need to find the slope. If I find the slope, if I said it was 0, your second derivative is 0, because it's a minimum here. But your first derivative is just the y value. 9 then, very similar, is my a value is -2, so you can see here, here, and here for that matter. And so this asking what is f prime at -2, I go 1, 2, I go up, and I'm roughly right here, so 1, 4, or around there. Okay. All right, on the back side, I don't have this whole worksheet on here, but we're going to kind of just go through all of them and what their functions are. So number 1, your function was 2x cubed, and your a value is 5. Number 2, your function is 4x cubed, and your a value is 3. Number 3, your function. Now you'll notice you have kind of two parts where that 2 plus h is plugged in. You have to use both of those as like pulling out and going back to what your original equation was. And so it's 5x cubed plus 8, and then the 2 with the h there, that's your a value. So that one's a little more harder because you have multiple terms. All right, 4, your function is 5 to the x, and your a value is 2. 5 is another one where you've got kind of a lot of things adding, subtracting. That's 6 at the end. That's what your function is with the value plugged in. So your function should have been 2x cubed plus 4x, and a was 1. 6, your function is just x squared, and your a value is 2. 7 was in your video, so that one was the x cubed plus x, and your a was 3, and was explained in the video yesterday. 8 then, you have kind of this weird fraction format, but that fraction of 2 over x, that is your function. And then here's where we start kind of getting to, I want to generalize these, not always have them at a number. They're plugging t in. So t is your a value, and we will explore that more as we go to 2, and what do I do for, like, if I have these things with just letters and variables versus like at 4, at 7, at whatever. So that will come a little bit more here as well. 9 then, your function is x cubed, and another one, your a value, excuse me, is p. They plug p into everything. 10, we throw a little trig at you. Your function is sine of x. Your a value. So you'll notice you see -1 right here. So it is whatever value, like the sine of what equals 1. You'll also see, so your answer is pi over 2. You'll see that you've got the pi over 2 plus delta x, so that's another y. But your sine of 1/2 is that that maximum. Sorry, losing my train of thought. And so you are at 1 at that value, and so that's where that 1 comes from.